Okie doke. Let's go through the homework. The question then. Who is going to talk me through this question? Luke.
So, so identify what's not being
So first of all, let's do the
targeted.
stock and seller thing.
So then you want to identify what's not being used. So this data is just X. Opposite is not being used.
That's the opposite here. Yeah, so that's
A adjacent is 6.4.
what?
Adjacent. Oh, what? No, sorry, wrong collision.
Yeah.
Adjacent is 9.
3.9.
And then hypotenuse is 4.7.
Hypotenuse is 4.7.
So we're using so we're
So
using
no O's.
So
cosine of theta is equal to adjacent over hypotenuse.
so it's cosine x equals 3.9 over 4.7. But then I think it's called invert. You want to do the inverse cosine instead.
Yeah, so x equals the inverse cosine of. Yeah. And we did that on our calculator. Function, inverse cosine, may 3.9 divided by 4.7. And brackets. So well, we get the answer. 33.923. This is where you can transfer it in the assessment. You can just click, copy and paste and put the whole thing in. So we don't have to remember or write things down. So we get x equals 33 points. Nine, two, three.
Yep.
Right, but it does say one decimal place, so we finished that with our answers. One decimal place is 33.0. Okay, good. Everyone got the same thing, everyone done it. Sienna looks like she's writing the answer down, she definitely didn't do it. Again. Ah, don't be sorry to me, you're the one that's going to catch up and bite you. Right, what we're doing today then, we are going to, you've got a few others you can get on with, but I wanted to consider the slightly more advanced ones, not much more to it, but there's an extra little bit of thinking going on. Right. So we've got a couple of questions here that involve a little bit of kind of problem solving. Not a lot, but a little bit. Okay. So let's read the question. It says the diagram shows a quadrilateral. So that's a 1, 2, 3, 4-sided shape. Now, quite nicely, they have split the shape for you down here with a dotted line. That's not part of the shape. Why has that been quite nice? What are they showing you already?
Oh, so it's like
Not what the actual shape is, actually, but
where the
triangles are. They're showing you that even though, so for instance, let me just do this, because this would be considered a slightly easier question. But if I did this look, if I gave you the question and it looked more like this, and you were asked to solve, would you think, oh, there are no right angle triangles involved? So that just rubbing that out as a question writer would make this question harder. But thankfully, for this example, we actually have all that in there. Yeah? Yes.
it would be like when something without that we
Like I said, remember I've said before that the first few questions are shorter, simpler, and the end ones are harder. Depends where, if this came up in your assessment, it depends where it is. You know, if it's one of the earlier questions, it'll be an easy one. But if it's an easy trigonometry question, you'll get a harder question on something else. If you get a hard trigonometry question, you'll get an easier one on something else. So that way of really knowing. Trigonometry is definitely, like some topics that you do are always going to be the harder ones. Trigonometry is one that could be easy, it could be hard. Okay, we've got to identify what we've been asked to do. Calculate the length of CD. So first of all, let's look at it. So CD is that length there. So that would suggest which triangle am I going to use? This one. What's the problem with that?
No lengths.
There's no lengths on it at all. None at all. Alright? So this would be the adjacent side. This would be the hypotenuse that I've got to work out. This side over here would be the opposite side. So if I went through so don't write this down just yet, but if I went through my SOHCAHTOA, my computer seems to be going funny. If I went through my SOHCAHTOA process, like this, theta, opposite, adjacent, hypotenuse, I'd write down that theta is 40, the opposite, don't know. Oh, come on, computer. Adjacent, don't know. Hypotenuse is the x. Alright? And I'd be crossing out my SOHCAHTOA, my SOH, my KER, and my TOA. So I'm stuck in this case. So what does that suggest? Actually, it doesn't. Not yet. It does suggest something.
Do you have to find any angles?
Potentially, but you know, I've got what I need in terms of the angle. But what do I need to find? Well, I need one of these other two, don't I? Well, it doesn't matter which one. One or the other would do. Which one do you think is the one that I'm going to be able to figure out? The opposite. Why? You're right. You're definitely right. I'm going with that, right? I can, if I highlight the thing, I can definitely find that's the one that I want to find. Why is that the one that's reasonable to find? Even? Yes, exactly. The opposite look of this triangle is actually part of this triangle. Now, here is the real exam thing, okay? Sienna, are you with us or are you catching up? Because if you're catching up something we've already done, we're then going to have to catch up with this. So stay with me on this. Yeah? I apologise if I'm wrong with my suspicions, but stay with me on this. That's not staying with me on this. No. Stay with me on this. Alright? Now, what do you notice about the purple triangle? Is it trigonometry? Look back at the front page where we did trigonometry. What did we write down what we need when we do trigonometry? How can we prep them? You jump. Why is it Pythagoras and not trigonometry with the purple triangle? Because we need an angle. If you look at the purple triangle, is there an angle? No. No angle. But we do have two sides, right? So this is quite often what happens in one of these more complicated questions. They bring Pythagoras' theorem and trigonometry together. Why do you think they go well together?
Because it's similar.
What do we use them to solve?
The angle.
They're both to do with what type of triangles? Right angle triangles. In fact, Luke, I'm just going to respond to that. They're not both to do with angles, are they? Pythagoras' theorem was nothing to do with angles, was it? It was just sides. Trigonometry was angles and sides. So Pythagoras' theorem is useless if we're trying to find, or useless on its own if we want to find an angle. Trigonometry has limitations. It's for angles and sides, but if you don't have enough information, you can't use it. So Pythagoras' theorem goes well with trigonometry to solve these kind of longer problems. Right? So I can probably now leave you to figure out what the opposite side is. That's what I think I'm going to get. The adjacent side I'm going to leave crossed out. Okay? Maybe it would be worth, unless you really don't think you need it, maybe it's worth getting your Pythagoras' theorem booklet out to remind you how to do it. But you are going to use Pythagoras' theorem to solve for the opposite. Now this is the opposite of this angle, but it's this side on the purple triangle. Okay? So step 1, Pythagoras' theorem to work out the opposite side. Step 2, use that to work out the hypotenuse in the other triangle. Okay? So, just finishing off this then, so reminding you that this side here, alright, now again, the 3.464 for me didn't make sense because of 12 and 16. So 10.6 being the correct answer. That was the shared line between the two triangles, so I knew that was the one to work out. And I end up with this. What's the final stage of working out x? Eden?
That's what's in when you calculate it.
I could. I don't actually have to. So actually like that. So x equals 10.6 divided by 0.6427.
Well, I simplified it, but I simplified it to 15.55.
So 558. Now, what does it say in the question? It wants to 3 significant figures. So we think that's going to be 15 points. 6. There's 1, 2, 3. Look at the fourth one. Does it round it up? Yes. So we can take that up to the 15.6. Again, I'm just going to go with that answer. I'm going to go back up here. I'm going to say that's 15.6 and just say, does it make sense? Well, that looks an awful lot longer than that, but is that a problem? Diagram not drawn to scale, not accurately drawn, but the number 15.6 is in the right kind of area. Just because that looks like it should be longer than that one, doesn't mean it definitely will be out of the calculation. But that number is not going to be 200 and something, you know. It's not going to be 1 point. Think about that double stage process. Let's just check then. Let's confirm. What did you have here? You had 10.58, yeah? No? So let's just compare this, guys. So 10.583, okay, so we get that divided by 642, just that. Okay, and you got an answer of, what was it? 16.46. Now, 16.46, 15.558. Who's correct? Did Alistair round it? Yeah, he did.
Not the 10, not the 10.
No, not the. So this one is more accurate, but the divisor is less accurate than yours, right? So, who is correct? Both of you. Both of you have the correct answer, just to different accuracies. Now, this is where you can see very clearly the impact of rounding your numbers in the middle of doing a calculation. All right? How do we counter the fact that our answers are wrong? No, not wrong. Different. We just show our working, right? We show what we did. An examiner can confirm that your answer is the result of your working. All right? Both of those answers I would happily give as correct answers. All right? Because, and 100% because, the working is shown. Yeah? They're not significant, they're 1 centimetre almost or over different, aren't they? But that is entirely down to rounding process. Now, can I get you to try something for me? Yeah? Because Eden wanted to change sine of 40 into that. Is that our calculator? Same way we did before, we do sine of 40 on our calculator. Now, I want you to try something. Now, what I'm going to tell you now, could mean our answer is perfect. Okay? So, instead of 10.583, what could I write instead? Well, where did the 10.583 or the 10.6 come from? Right, so what if I didn't change this? What if I left it as the square root of 112? Do I need to round that at the moment? No. Okay? Divided by, well, where did the 0.642 come from? Sine 40. Well, what if I left it as sine of 40? Is it possible to do that calculation like that without doing it turning into decimals? Alistair's already trying it. Well, let's go to that calculator that I told you about. All right? Let's do it. We've got cosine, inverse cosine of, and I'm going to do the square root of 112. Oh, too many. Right? That, I'm going to use my arrow to come out the square root. That divided by, what was it? Sine. I'm not, yeah, that should be sine of 40. I've left something in there that shouldn't be there, which is the inverse cosine bit at the beginning. So I'm going to go back there and I'm going to get rid of that. Remember, this is your calculator that you'll have access to on the e-assessment. So you can do this on your e-assessment and press that button to paste it in. Right? What answer do we get? 16.46. 16.464, and I don't have to round until the very end. 16.464. All right? We actually get, Alistair's was a bit closer. All right? and I would give my answer finally as 16.5 because it's three significant figures.
So if you had, if I did that,
I would say no, as long as you show me all your work. Alright? But what I'm doing there, I would like you all now. Can you practice doing that on your on your laptop? If you get your laptop and get this Desmos scientific calculator out. This is now, I'm really struggling to get you to have your e-assessments in front of you, but the least I can do is get you to use the e-assessment calculator. Can you practice putting that in without having to do any rounding? Can you actually do that? Check you can use it?